Okay, now we're on. Good morning, class. Uh, Welcome to this Wednesday, historic day, um, because we're going to learn about lists. The thing is, I'm not sure how interesting I can make this lecture because I already showed you what a string was. And a string is a list already, right? We just sort of showed you strings because we could show you a string without really getting into like the technical details of lists. But everything that's going to be true about strings, okay, many things that are true about strings are also going to be true about lists in general, like slicing and indexing and how they're stored. So before I want to show you a list, I actually want to tell you about a structure, data structure that's actually simpler than a list. It's called a tuple. So a tuple is an ordered sequence of elements. An n-tuple is a tuple with exactly n elements. You know what this word is, right? Because we call pairs couples, triples, quadruples, and that's where that term comes from. These things are called tuples. So in Python, you can use the round brackets to create a tuple. But the thing about tuples, like strings, is that tuples are immutable. That means once they're made, you can't change their values. So here I've created a couple, 1, 2, like a coordinate. Python is going to tell me that the type of this is a tuple. As I said, tuples are immutable. So if we ask for the element at the 0th index, that's going to give us 1. And if I try to change the index, if I try to change the element that's at index 0, I'm going to get an error. Right? So tuples, like strings, can't be changed. Okay, so a list is basically just a mutable tuple. Right? So take a tuple, make it mutable, and suddenly we have a list. Right? So a square bracket is used to create a list in Python. So I can say x's is equal to square bracket 1, 2. That's going to create a list of 2 elements. I can ask for the type of x's. It's going to say type is list. So that's wrong, not tuple. I can ask for the element at the 0th position. That will say 1. And now I can change. I can say that the value at the 0th position is twice the value at the 1st position. So if I ask for the value of x's at 0, what should this be? 4. Perfect. Okay, so for the rest of the day, I'm just going to show you all of the list built-in commands. Right? So today is just about, like, I'm just going to throw, like, a dozen commands at you, and then Friday, we're actually going to do some, like, list, like, programming with lists. I'm not going to do much programming today, unless I have time. Okay, so you can ask Python for what built-ins are available for a data type, right? So in this case, if I say dir list, right? So I'm asking Python to give me all of the available commands for lists. So if I type that into the Python compiler, this is going to show up. Now, I want to just focus on the stuff at the end, the stuff that's in magenta, but it's good to know that these other names, the ones with like the double underscore, this is a special naming convention. These are sort of private functions to the lists, right? So this says that like we can take 2 lists and compare them, right? This is probably the less than operator. This is probably the the method that Python uses to grab an item from a list. So eventually you'll understand specifically what these mean, but today I just want to focus on these ones. So if I have a list and it has 3 elements, suppose I want to add an element to the end of this list, right? I want to construct a new list. So I can say, take the list x's and append to it 3. And if I ask for x's, it's going to add a 3 to the end of it. Now, I should have looked this up, but I'm 80% certain this isn't duplicating the list, right? That this is just adding 1 extra element to the list that you have, right? Because I am certain of this. For those of you who understand, lists in Python are linked lists, right? So which means that you can quite easily add an extra element. So with strings, whenever I created a new string, because they're immutable, I had to keep copying the string in order to do anything to it, which could be bad. So for list, you can imagine having a list of 1,000,000 elements and wanting to add the 1,000,000th and first element. It would be a bad idea to have to copy the list. This is equivalent to the following code. So I say code equivalent because I'm not absolutely sure if they're technically equivalent. But they will give you the same result. So that's why I say code equivalent. So you can either append to a list like this, or we actually have the ability to concatenate lists, right? So I can take a list, and then I could add to it another list, and it's just going to make one super list out of both of them. The clear command is going to take the list off. Well, it's going to empty the list, basically. So if x's is equal to the list 0, 1, 2, I can clear this list and then ask for what the value of x's is, and it's going to be empty. Right? So this is how you can just sort of like empty out the list that you're working with. So this is equivalent to just, well, what is this equivalent to? What equivalent statement can I write to empty a list? Yeah, just to the empty list. Okay, but so to speak technically, again, I think it's better to do the first one. Because the first one is actually going to instruct Python to release the memory of that list. Right? So you can imagine you have some list that's filling up memory, and you clear it. So Python says, okay, that's space available again. Whereas in this one, it's going to leave that other list in memory and create this new list and move the pointer. List copy. So I can have a list. Let's call it x's. I can say x's is equal to the list 1, 2, 3. I can say y's is equal to the list x's, and now I'm going to take the list y's and I'm going to change its last element to 9. What is the value of x's? Okay, what are the two options, right, for x's? If x's wasn't touched, then x should still be 1, 2, 3. However, depending on what it means to be equal to another list, x's could have been changed. So which one do you think it is? Do you think x's was left untouched, or do you think x's was changed? You are correct. Even though that is the incorrect output. It's not even close to the correct. That should be 1, 2, 9. Yeah. This is wrong. Right? Down there. 1, 2, 9. Right? Was that the I see some confusion. What can I help you out? Okay. So when you make a list equal to another list, so these variables aren't really containing the list. Like the variable is basically saying the list is over there. And I'm pointing at it, right? And now when I say y's is x's, I'm saying, oh, okay, I'm going to point at the same thing x's is pointing at. So these are called pointers, right? So another way of putting this is x's, the name x's and the name y's aren't storing the list. They're storing the address of the list in memory. So this is actually just copying the pointer to the list, right? So you're not, when you do list equality, you have one list. Do I have chalk? Yeah. So in this case, I had x's, and in memory here, right, there is the list 1, 2, 3. Okay? And when I say x's is equal to this list, it just sort of does this. So when I say y's is equal to x's, I'm actually just saying this is the case. So now I have two names pointing at the same thing. So any changes to one will change the other. Right? So maybe I should go into Python a bit. Because this is important. This is probably something we're going to try to trick you on in your exam. Right, so here's x's. I can get the elements of x's like this. I'm going to now say y's is equal to x's. All right, so there's y's, there's x's. I can say the 0th position of y is 10, but that has also changed x's. I can say let's append to x's 9, but that also changed y's. Right, so we just have duplicate pointers, right, at a list. So this is a very important nuance. Yeah. Well, let's check. X is equal. No, well, I can't do the same experience. I can't do the same experiment because strings are immutable, right? So I don't think the same thing. Like, it is the same for strings. You're just getting a pointer to where it is, but like there's no other consequence to that because you can't change them, right? Okay, so how are we going to solve this problem? Like, what happens if we actually want to have 2 lists? Well, there's this command called copy, and I bet you can guess what copy does. I can say, here's a list x's. Let's make a copy of that list for y's. And what that does now, when I copy, is this copy is actually going to go into memory and create another list. Right? So this is what copy did. It just made this duplicate. And now y's is going to point at this new list. Right? So we have, like, really do now have 2 lists in memory. So I can change the last element of y's to 9, and x's is left untouched. And y's has changed. Right? So because now we do properly have 2 copies of the list. Count. If I make a list x's, that's 1, 2, 2, 3, 3, 3. And I count the number of 2's. Anyone want to hazard a guess? 2. What happens if I count the number of 4's? 0. Yeah. Not error. 0. Okay, so I'm going to up the difficulty. So this is a list whose elements are lists, which is fine. You can make as many, like a list element can be anything, including a list. Right, so if I have this, so this is, what is the length of this list? X's. 2, perfect. What is the count of 2's in this list? 0. You guys are good today. Right, because what's the count of the element 333 in this list? 1. Anyone? I suspected that you guys were going to be really impressed and confused by this, but too smart for me today. Extend. Suppose I have a list, and I want to add like multiple members to it. So I want to add, 4 and 5. So if I used append here, what would happen? Right, it's going to create a list, and it's going to then append another list as a single element, right, to that list. Right, so what you want to do instead to extend the list is to use this keyword extend. And what this is going to do is extend the list as we expected. This is code equivalent to just concatenating the list. But you should always use the list built in, right? Because you should assume that this is going to be implemented more smart than these higher level operations. Because I assume that this is just going to, I'll have to check. These may be equivalent. Okay. Index. I think you guys had this for strings. It's like a lot of these string operations have like a list equivalent because a string is just a tuple of characters. So what happens if I ask for the index of C in here? What will it be? I heard people whisper the answer. It's 2. Okay, but what happens if I ask for the what is at the position of the index of C in X? C, yeah, it's a, whoops. That should be C. I'm not doing very well today. Because it's an identity, right? The thing that's at the position where the thing is at is the thing. It's a great sentence by me. Here's another list, A, B, C, B, B, D. What is the index of B? 1. So the index always gives you the leftmost position. But if you, what's the index of E in here? The letter at -1 is D. -1 is a valid list position, right? No, dot find would also not. If dot find returned -1, that's also wrong, right? Negative indexes into a list exist, right? The x's at -1 is D, right? So what other options do we have? It can't be, like, you're on the right track. You're trying to give some type of index that doesn't exist. Like maybe float inf would work, but in fact, we're going to get an error, right? You can't find something that's not there, right? If we were in C or something like -1 or false, like maybe false would be an okay thing to return here. But since false is equal to 0, that like has all of these other, it could really screw up things. So you just get an error here. But you can always, before you index, you can say something like, my index is, well, okay, I'll show you in Python then. So here's x's, 1, 2, 3, 4, 5, 7. Right, so I can get the index of 7. I can also ask for the index of 9, and that's going to give me an error, which is bad. Right, so I can always say that, like, if I want to store my index as k, I can always say k is, what was I doing here? K is x's dot index of 9. If 9 is in x's, else, I don't know, set it to some default value, like float inf. Right? The if executes before the thing on the left. Right? So you can always check to see if your element is in before you're actually doing a find or yeah. What? Is? Where did I type is? Oh. Sorry. Should be in. Well, because is a keyword, technically, right? Okay, so have you ever guys tried to do a type check? So if I have x is 9, you know that the type of x is int. Okay, so how would you type check x as an integer, right? Most of you would probably want to do this. Right? That's what you'd try? Well, this seems sensible to say is the type an integer, right? But like when I type this, right? This, what is the type of this? It's a string, like it's not a type itself, right? So I have to say this instead. Type of x is int. Whoops. Huh? Oh. Right? The is specifically used in this instance to distinguish between the name of a type and the string equivalent of that name. Right? So that's what is does. If you ever want to do a type check, yeah. If x was a float, I can still ask if it's an integer and it would return false, right? Right? But it is a float, right? I shouldn't have taught you this. Now you're all going to do crazy type checking on your assignments. Insert. So I have a list and I want to put something in the list. What happens when you can ask for the length of the list. This is the first time I've mentioned it. But suffice it to say, you can ask for the length of the list. So the length of this list should be what? 6? 6. So the syntax of insert is as follows. You're going to... So do you see how I'm calling these things, by the way? This is sort of different than using a function. I have a list x's, and I'm using this dot, and then I'm calling some command. I'm calling a function. This will make more sense once we introduce objects to you guys. But in any case, this is going to insert at position -2 in x's, the number 9. Right, so if I run this, what am I going to get? Well, what's going to be the length of my new list? 7. Okay, so this is going to insert 9 at the -2 position, which is -1, -2. So that 4 should be to the right of 9, and there should be a 9 to the right of 3. There we go. Right, so this is the -1, -2 position. So this is now at the -3 position after you've muted the list, or after you've affected the list. If I ask for the length here, we can see that the length is increased by 1. What happens if I want to insert at the 100th position a 9? What do you think a sensible thing for Python would be to do? Would it be to loop? It would be one way of doing it. What's another way we could do it? So just put it at the end then, right? Okay, that's the right answer, right? But that would be good as well, although it would be a lot more work to implement if you wanted to do it cyclically, right? So this is just sort of more efficient to say, look, you don't have a 100th position, so I'm just going to put it as close to the 100th position as I can. An additional option would have been to pad the list with something, right? To have it actually at the 100th position, but then I don't know what you would pad with. Oh, this is my favorite list operation. I can't tell you how useful this command is. Because this basically is an implementation of something, a computer science data structure called the stack. And a stack is so important for programming, I just can't even. So this is how pop works. I have a list. This one has 4 elements, 0, 1, 2, 3. I can say pop this list and assign the result of that pop to x. So x is going to get 3, and the list now is going to look like this. Okay, so I'll show you what a stack is in computer science. Right, so we have something called the stack, and it's just a data structure. It's like you have books, right? And you have to stack the books on top of one another. And you could take the top book off or put a new book on, but you can't take this book out. Right? So in this case, we have something that looks like this. Wait, did I start at 0 or 1? 0. So when I pop something, that's just like taking the top book off. Right? So I pop, this comes out, and this goes away. Right? Then I have that 3. So this pop routine is basically just implementing that. So I want to show you something, what I can do, how you typically work with pop. 1, 2, 3, 4, 5. So suppose I wanted to work my way through this list and do something for each element. I could do something like this. While x is, right, so remember that bool of anything that's not empty is true. Bool of something that's empty is false. So I can say while x is has elements, basically. Well, I can write that in. Whoops. While x is has elements. 1, 2, 3, 4. Let's print x's.pop. There we go. And then our value of x's is empty. So it's like if you had you could use this for your Sudoku thing, right? If you wanted to work your way up and then back and then up, this is how you would be able to do it. Or if you have a set of tasks that this is easier to explain to my Australian students because you guys line up for coffee. The Australians queue for coffee, right? So this is basically like a queue where the person who shows up last gets to go first. Anyways, this is a very useful command. Remove. This will remove an element from a list, right? So if I ask to remove 5, what's going to happen here? And note that there's 2 5s. So what has been the convention of Python when there's been multiple instances of an element in a list? Well, it works from the left first, right? So if I remove a 5 from here, it should remove this 5. What happens if I remove 5 again? Yeah, remove the last 5. What happens if I remove 5? Okay, you say error. What would be another sensible option? Just return the same list. Okay, but you're right the first time. It's an error. I personally think this is a stupid base case. I should be able to remove a 5 from a list, right? Removing 5 from 0, 1, 2, 3 should give you back 0, 1, 2, 3. I would not expect, I should write the Python people. Mathematically, this doesn't make any sense. Maybe there's like an implementation reason here, but I don't like this. You guys are allowed to have opinions like this about how Python works. Remember, we're part of the Python community, right? We can say, no, this is really confusing and should not have been set up this way. But anyways, yeah, so if you want to remove something from a list, you're first going to have to test, you A, have to be sure it's in there, or B, look that it's in there in the first place, right? I'd probably just write something else that would implement remove the proper way, in my opinion. Okay, so let's try writing something. Let's write a function that removes all instances of x from a list, right? Because we're going to be able to use while. There's one thing I need to tell you about types. Now, in Python, I can do something like this already. I can say foo x, take a list, and return a list. Okay, that's fine. But suppose I have a list like this, right? A list of integers. And I want to say something like, I want to create a function which takes a list of integers and returns a list of integers. That's going to give me an error, right? So in order to have more descriptive doc strings, I'm going to call in a library, this typing library. So specifically from typing, I'm going to import the list, capital L list type. And what this is going to allow me to do is define what? Oh, sorry, that's small l. Okay, right, so in order to get these more descriptive headers, we're going to use the typing library, just so I can be way more specific about the type of list that I'm taking. So what did we want to write today? Remove all. Okay, so maybe I can do this in Python. Let's not risk it. What day is it today? Wednesday? So remove all. Okay, so def remove all. And what was I taking? X's, which was a list of integers, and x. And I want to return a list of integers. From typing import type, or list. What? List. Removes all instances of x's from x, right? So maybe we can have something like remove all 1, 2, 2, 3, 3, 3. I want to remove 3 from this, and this should return 1, 2, 2. Right? It's also good to throw in an edge case here. If I remove something from the empty list, it should just return the empty list, right? And I'm going to do this the way that I want to do. If I remove, let's say I want to remove 7 from here, I'm just going to say this. Because in my opinion, this is a much more sensible operating. How can I do this? Remove all instances of x from x's. While x is in x's, remove x from x's, and then return x. That's it, right? Fairly simple. Let's see if this works. Oh, sorry, x's. Aha. Perfect. Great. 1, 2, 3. Perfect. I'm going to give you a little preview of a Friday. Here's another way that I could do this. X for x in x's if x not equal to x. Oh, I can't use that twice. T for t in x's if t is not equal to x. Yeah. So this is something called list comprehension. I love it. Right? This is a feature of Python which really attracted me to it because this is basically like set comprehension in Python. So there's two ways of doing this. So the first one's probably more understandable and more useful because this is a good example of when we need a while loop. Okay, reverse. Who can guess what this does? It reverses a list, so let's not talk about it very much. But can someone remind me what the equivalent would be? Yeah, and I'm sure you would have had the same answer up there. So remember that that's equivalent to this. Sort. So I'm going to give you the ability to sort a list, but we're going to have a serious conversation about how we sort. Right? This is a very important problem in computer science. You can think about it a bit. If I give you a really long list of numbers, how you'd go about sorting those numbers. So what will be the result if I sort this list? Or failing that, tell me what the two options are. Yeah. It would fail. Why would it fail? You can sort anything as long as the things that you're sorting are comparable. So the fact that there's a negative number in here shouldn't bother you. What I'm trying to get at is, how are we ordering? Ascending or descending is what I'm trying to get at. I'm trying to get you guys to guess, am I going to sort in ascending order or descending order? Yeah, I'm asking you to guess. Just guess, mate. Because you're being so difficult. Yeah. I would say, yeah, ascending would be the more natural default, right? Because you usually list things in ascending order somehow, like alphabetically, you're counting. You can reverse it by just giving this option, right? So here's the first option I've ever showed you. Right, so often it is the case that functions have default values, and you can actually change those default values. So when I called x's.sort here, hidden underneath the hood, it had set this reverse trigger to false. It's like false by default, but I can actually set it to true. Because this, like, building the list in descending order is faster than building it in ascending order and then reversing it. Right, so this does make it a little bit more efficient when you throw in these options. Okay, we can compare lists, right? Because I showed you one of the built-ins at the very beginning had a less than operator. So what should this evaluate to? No, it's one or the other. Commit. True. I'm not going to tell you why this is true yet. Let's see if we can like backwards engineer it. What about this one? I just changed this position. Someone make a guess. Good. False. It's point-wise comparisons from the beginning. Right? What about this one? True. Ponder why that may be. It's hard for me to explain this. I could explain it because recursively this is very clear. Recursively, the base case is empty, and you have to pick true for like. There's a very good mathematical reason this is the case. You're just a little bit. You don't have enough mathematics for me to explain it sufficiently. But just so I can really drive home the point here. So 1, 2, 3, 4, 5. Is this less than minus 2? Remember, point-wise comparisons from the beginning. Okay, what about this? True, right? Point-wise comparisons from the beginning, right? What about this? False, yeah. Okay. Slicing. So remember how we're slicing with strings? You can slice in the similar way lists, right? So this is a special list. Its index and element are the same. So if I slice x's from 3 to 6, what list should I get back? 3, 4, 5. Remember, it's a cut that's inclusive on the left and exclusive on the right. Same as strings. What does this one do? Yeah. Every second number starting from the 0th position. What about this one? Okay. So let's think about this is a perfect midterm question. Let's figure out what this is saying. It's saying, I want you to cut the list x's from the 7th position to the 2nd position, stepping backwards by 2. Right? So if we start at the 7th position, that's 0, 1, 2, 3, 4, 5, 6, 7. Okay, so the first number in it is going to be 7. I have to skip by 2's, 5, 3, and then I'm already beyond the boundary. So 7, 5, 3. Right, so it looks confusing, but if you just sort of like read out what it's saying, right? Slice from 7 to 2 while stepping backwards by 2. Right? That should help you with this. The last thing I want to give you today, but don't pack up and move because it's this and then one more thing. It's possible to take the brackets off a list and change it back into a tuple. And this is useful in this scenario. Like suppose you have a function, so it's defined a simple function f here, and all it does is take 3 numbers and add them together. Now, suppose you want to pass 3 numbers at the same time. You're saying, okay, I have this list, 1, 2, 3, and I want to give it to the function. Right? So one way of doing it would be like this. If I had some type of x's like this, 1, 2, 3, I could always call f like this. Right? But it turns out that I can do this instead. I can say, well, first this. If I give this x's, what's going to happen? Yeah, it's going to say, look, you've given me one thing. Right? I'm expecting 3 things. You gave me one list. You gave me one list comprised of 3 elements, but nonetheless, you only gave me one thing. So I can actually say, take the brackets off of this, right? And then it will work. Right? But it won't work outside, right? It just works specifically in this instance of unbracketing for the sake of passing arguments. Right, so this is just a little bit of an advanced technique for those of you who ever find yourself in the need of unbracketing something. So Friday, we're going to get really seriously into this stuff, right? We're going to be, so I want you to go home and like practice with loops, because Friday you need to be basically well acquainted with them, or you're going to be very confused, right? Because we're going to do looping over lists, range, loop nesting, nested lists, and list comprehension. So specifically next time by the end of class, I hope to write a program that does matrix multiplication. So also remind yourself how to do matrix multiplication from high school. And I'll see you Friday. Enjoy your Thanksgiving.